let's pin that video. There we are. All right. Related rates, another part of the test on Friday that did not go well. Awful lot of blanks. Understandable. It takes time to learn this stuff. We're on the fly. Again, short semester. But let's hope that we can get a few more right on Tuesday's test. All right, so something you're familiar with, y equals x squared. So the derivative being 2x. If we move dx to the right side, it mimics the point slope form of a line. And what do we use these formulas for? Slope, right? 2x assigning the slope to that curve. And there's lots of derivatives that assign slopes, tangents to different curves, slopes of the tangents. Okay? But it's this notation that we want to be mindful of, because in some of these formulas, maybe the side of a cube is changing at a different rate than some other cube is. So we begin to differentiate with respect to time. And so we got 3s squared ds, and we bring in that component. I've done a video on that. That's the one throwing the pebble. I think I've done two, throwing the pebble into the pond and looking at those table values. Spent a lot of time making that video. I hope you watched it, all right? Because if you're going to understand this stuff, you got to put that kind of time and effort into it, all right? So I'm hoping that is something you did look at. If you haven't, go to the video. It's on this my YouTube channel, all right? Look for it, related rates. So we have all these formulas. Volume of a cube, area of a square, surface area of a sphere, volume of a sphere, our Pythagorean relationship. And then they get a little more challenging when you start talking about more than two variables in a formula where you have to name one in terms of another. We're not going there. We're still trying to sort out the basic entry-level problems. So let's tackle I guess we'll tackle the ladder problem. I don't remember offhand all of the values. I think it was a 7, 24, 25. I don't know if you noticed. I put that information on the board in front of you. I gave you some instructions on the board, and I had 24 times 24 equals 576, hoping that it might be helpful. But I'm not sure if it was or not. All right, so the ladder's coming down the wall. And I think the ladder was given as 25 feet. And then we got, our X and our Y. Could have called it something else. Could have called it the floor. Could have called it F. Could have called it the wall, W. Doesn't matter. What matters in these problems is writing the geometric relationship. And we have a 90-degree triangle, and we want to write down, to get started, what's the relationship? The relationship is x squared plus y squared equals 25 squared. That is mandatory. All right? We don't want to I know there's information there about when the ladder's 7 feet from the floor. Okay? Don't ignore that at the beginning. Write the geometric relationship. Now, the next step is, what happens in this geometric relationship? Well, Pythagoras says it's the square areas. That these two areas add up to that one. And if this one is constant, if that's constant, and this one gets bigger, we know how that gets bigger. We've studied that from day one. That layering process. Then this one has to get smaller proportionally, because this area is not changing. So whatever that area is, it has to come out of this square. So if one's getting bigger, the other's getting smaller. If this is a positive change in the ladder's width, what do I want to call it? Its distance from the wall. If its distance from the wall is increasing, then this is decreasing. So one's a positive, one's going to be a negative. Or you can write down it's decreasing at a bump to bump ratio. Okay? So now you might want to look at the word problem again. I think this was maybe going out at 3 feet per second. If that's going out at 3 feet per second, then we now know that dx dt equals 3. We could put the units of measurement in feet per second, and it's nice to watch those units work, but we'll just work with the numbers right now. All right, so that's a given. And what's a given is the y value is 7 feet from the floor. So we know when y is 7, we're going to be working with. Okay, and I think we're to find dy dt. I think that's what we're trying to find, dy dt. Okay, so let's see. Let's go over here. And yes, enough work. So we know that x squared plus y squared equals 25 squared. So now we look at, okay, what's going on here? Oh yeah, that's an x, that's an x, that's a dx, that's a dx right there. That's a 2x dx. And we know the same thing's happening over here, except it's on the inside, right? We got to come up with some proportionality here. So that's a 2y dy. And if anybody sees the area of this change, let me know. That's 0. All right, and we said that this is changing at a, I've been on a ladder. You know, they used to call me Jim No Paint. My roommate was Brad Paint. He put a lot of hours in. I didn't put so many in. But I was on a ladder, and I did get to the top of the ladder, and I had a nice ride down the wall. Nice, big, tall ladder. And I can attest. Interesting experience. This was given, dx dt. We're trying to find dy dt. I think I can divide by 2. X, dx, and I think I can put in dx dt right now. It's 3. Not to write the number, then the parentheses. And I'm going to divide by 2, and we can find y. We can find y. Yeah, this was 49. This was 625. I thought folks would get that far, and I think that comes out to 576 when you subtract that. And on the board, I had written 24 times 24, anticipating somebody asking me what the square root of 576 was. Unfortunately, nobody did, because I was going to give it up. I was going to give it up. So, 24. So first off, we're dividing by 2. And so now we know that that's 24, and this is 7. This was 7, excuse me. So this is 24. This one over here was 7. And I think we got ourselves a one variable equation. So we got 72 divided by 7. I don't think that was the numbers that I gave you on the test, but same kind of problem. So 72 goes to the other side, becomes negative 72. We divide by 7. And that's our change in height with respect to time. That's the rate at which the ladder is going down. It's decreasing at about 10 feet per second at that instant. So the closer you get to the ground, faster that ladder's coming down. That's a related rates problem. If we wanted to do volume of a cube, all right, let's do a related rates with a volume of a cube. That's even less work. So we write volume equals S cubed. That's where we start. Volume equals S cubed. What do we do? Well, there's 3 things. There's the volume, there's the side length, and then there's ds dt. And you might want to ask, how many of those am I going to give you? Which 2? Does it matter? Does it matter which 2 I give you? dv equals 3s squared ds. Boy, we've done that a lot this term with those layers on the box. I don't know, which one do you want? we want, I suppose, I'm sorry, I should be giving you it's a related rates. I'm gonna give you dV/dt, or I'm gonna give you ds/dt, right? So I should have said that right along. I was just looking at the geometry of the problem. So now, those are the three things that you're gonna really be dealing with, and I'm gonna give you two. So what do we wanna give you? How about I give you dV/dt? Say it's going up at 10 cubic centimeters per second. ds/dt, I'll give you ds/dt. Let's say that is changing at 2 centimeters per second. Now the question is, I guess, what's the side length of the cube? Well, let's put the numbers in and find out. All right, so dV/dt, 10 centimeters cubed per second, is going to get divided by 2 centimeters per second. Okay, seconds can cancel, yes. So we got 5 centimeters squared. Oh, and I guess that's going to get divided by 3. And that's s squared. I kind of like that because when I take a square root, I get centimeters. And I think that should be what the side of the cube should be written as, certain centimeter length. So what is it? Square root of 5/3 centimeters is our side length in that particular instance. I hope that's fairly straightforward, and it's coming your way again on Tuesday. So we're done. Now I'm going to go correct C block, see how they do. All right, then I'm going to send you an email, let you know there's a couple of videos to look at. And you can also look at YouTube videos, right? There's tons of these things out there. Why don't you practice a couple of ladder problems or the dinghy problem that I uploaded a while back. Some woman did it. She did a nice job. There's lots of these things out there if you want to practice before Tuesday's test. The better you do, the higher your grade. All right. Worse you do, well, we're not going to.